Okay, number 10 says it has a function f of x, and this is g of x, and this is h of x. And it says, consider the following, which are true, okay? Which of the followings are true? So the first one is f of x is equal to g prime of x. That means that if you take the derivative of g, what would the derivative of g look like? It would look like f. So make sure you're understanding the order of this. It doesn't mean that g is the derivative of f. It means f is the derivative of g. Okay? So if we look at g, this is the original function then. It's increasing from a little before -2 to 0, and so that would apply to be positive if you're looking at the first derivative. And sure enough, the first derivative is positive. And then it is decreasing till 2, which should make negative on the derivative. And sure enough, from 0 to 2, it's negative. And then it starts increasing again, so that would make it positive. So that's definitely true, okay? Number 2 says h of x is the derivative, h of x is f prime of x. So that means take the derivative of f of x, and it should make h of x. So now I'm going to erase this stuff. You're saying that this is the derivative of that. Okay, so we'll look at this. This function is increasing a little tiny bit till 2, and then increasing and then decreasing, which would mean the derivative is negative here, decreasing all the way to 2. At 2, it starts to increase. So you should have it negative from -2 to 1, and then start to be positive at 1. So that's definitely true too. All right, and let me erase the next one. G of x is -2.5 to x of f of t. So they're saying that g is the integral of -2.5 to g of f of t. And isn't that just saying that it's the same thing as saying that g prime of t, so take the derivative of that, isn't that the same thing as f of x? So if we put a d dx here, don't we get f of x? And we already said from number 1 that that was true. So it would be D, all 3 of those are true. Let's go on to number 11. Okay. You got some copper being made at an increasing rate, and they give you the original, they give you f of t. So, and f of t is measured. What definite integral gives the total amount of copper? So this is accumulation. So from year 0 to the beginning of 2005. So it's just going to be the integral of 0 to 5 dt, or you can put the function in. Then it says write out the terms in the left and the L5. That's a Riemann, a left Riemann. So they want to see, you can do a left Riemann from a function. So you would put year 0, 1, 2, 3, 4, and 5 right down. Now the hops between these are only 1. And you don't use the last, so I put a 1 because they're all the same. And then you would take f of 0. You would do the 0, 1, 2, 3, and 4, and not the 5, and add those together. So that's a good example for B. And then C is a good question. It says, how good an approximation is L5? I can see this being on the AP exam. They're going to make you do a Riemann, and they're going to say, how good is approximation? And if you look, our function is going to keep increasing. It says it's increasing. So here we have an increasing function with a left Riemann sum, and an increasing function with a left Riemann sum is an underestimate. So you would say L5 is an underestimate because you're using a left Riemann and the function is increasing. So that was example 11. I think we have one more. Oh, example 12 is really good. let's look at it. We have 3 functions, and they're going to make us combo stuff. So we have negative 1 to 4 of f minus g of x, and you can just use your rules to split that up. That's equal to negative 1 to 4 of f of x minus negative 1 to 4 of g of x, and so you just do 6 minus negative 3, and you get positive 9. I can remember this being like on a test. Then we have 0 to 4 of g of x. Now look, we don't have 0 to 4 of g of x. We have negative 1 to 4 of g of x right here, and negative 1 to 0 of g of x. So look what I wrote. 0 to 4 of g of x is what it's want, is equal to the bigger one, negative 1 to 4. And then take away negative 1 to 0. That'll give you 0 to 4. So I wrote that out. So negative 1 to 4 of g of x is negative 3. And then you take away negative 1 to 0 of g of x, and you get negative 1. So 3 minus negative 1 would be 3 plus 1, or negative 2. And then they want 2 to 7. You don't even have that, but you can use u substitution. This is a little tricky, so it's good I'm showing you this. If you let u equal x minus 3, you're going to change these guys, and you're going to hope that everything works out. So 7 minus 3 would be 4, and 2 minus 3 would be negative 1. And so you can rewrite it negative 1 to 4 of f of u du. And now negative 1 of f of u du is going to give you 6. So the answer would be 6. Okay, so that's kind of cool. All right, that was the work for R16, and now I'm going to skip the classwork. I think that your homework, doing the homework, will be the equivalent since we're not in class. We don't have to do that this time. All right, so do the homework. It's really good practices from Barron's, and have a good weekend.